Hello students, my name is Sumit Sagar Hota. I am a PMRA PhD scholar, IIT Palakkad. Today we will discuss week 12 extra sections. Okay, in this section we will discuss some of the extra problems and extra MCQs related to your week 12 section by Professor Ashok Des sir. Okay. So the prerequisite for this section is you should go through week 12 of the section by Professor Ashok Des sir. Okay. The subject introduction to air breathing and combustion. Okay. Sorry, and propulsion. Okay. So let's start with the first question. The reaction turbine is also called as what? Okay. The reaction turbine cannot be the impulse turbine, it cannot be Curtis wheel, it cannot be Pearson turbine. Okay. So the answer of this question is D. Okay. Okay, so the reaction turbine is a what? Velocity compounded turbine. Okay. Sorry. So the for this question, reaction turbine cannot be none of the mentioned, because otherwise why this question is asked. Okay, there is a confusion. So answer of the this question is what? C. Okay. Okay, so answer is C. Why it's C? Because the reaction turbine invented by Pearson. Okay, so it's also called as what? Pearson's turbine. and both are same. Okay. Compounding is used for dash power application. Okay. Compounding is done means there should be some high power. Okay. Okay, the compounding is done for what? High power applications. Okay. Okay. So what does it mean? This high power, whatever the high power is there, okay, produced at low speeds. Okay. So high power application used for what? Producing low speeds. Okay. So that means if the speed is low, sorry, the power is low, that means what? Okay, that means the speed will be high. Okay. So if the two question can be formed, if they will ask in terms of speed, also you can answer now. Okay, and if in terms of power, also you can answer. Okay, so two way can be. Okay. Next question, in velocity compounded turbines, flow passage is from dash. The velocity component turbine is a flow passage is from what? Answer is here D, none of the mention. Okay, this is a tricky question. Okay. Okay, so velocity component turbine means what? Okay. Okay, so velocity compounded turbine. Okay, so it will be what? The flow passage is from fixed nozzle to multiple rows of moving blades. Alternating with fixed belts. Okay, so this is what the your velocity compounded turbine about. Okay, next question. A velocity compounded impulse turbine is also called as what? Okay, it's called what? Curtis wheel. I already mentioned. Okay, I can remove it and I will write down here. Okay, in my handwriting. I write down, but I will still prefer to write down in my hand. Okay. Okay, so the answer is A. Okay, and what is the answer? Curtis wheel. Okay. Curtis wheel is a velocity compounded impulse turbine. Okay. Okay, and why this Curtis wheel? Because this velocity compounded impulse turbine invented by Curtis. Okay, his name Curtis, so it's called Curtis wheel. Okay. A turbine comprising of fixed blades and moving nozzle is called as reaction turbine. Okay, absolutely correct statement. Okay. Reaction turbine means what? The reaction produced when steam hits the turbine. When steam hits the turbine, and the reaction produced when the what? Steam hits the turbine. Okay. Also used to produce work output. Okay. Next question. Losses occurred while passing through the blades are called as what? Answer is B. Blade frictional loss. Okay. The losses occurred while passing through the blades are called as blade frictional loss. Okay. blade the friction between blade and steam. And the loss occurs due to that friction. Okay, for fixing blades and rotating components together are used dash. Okay, okay, together are called what, or used what, it's glands. Okay, so glands used to fix blades and rotating components together. Okay, the losses occurred at the gap between the glands are called as what? So obviously if there is a loss means, and which is occurring at the glands, if you don't know anything, loss is there, glands is there. Okay, what do you combine it together, will be your what, gland loss. That's it. So these are simple questions, this also can be asked. Okay, 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 gland loss. Okay, kinetic energy that steam has while coming out of turbine is called as what? So next answer is A. Kinetic energy that steam has while coming out of the turbine is called as what? That is your residual loss. The residual loss. The loss that steam contains. While exiting the turbine. And this energy cannot be used. And called what? Residual loss. Okay. This question directly taken from your assignment. Okay, because some of the people are telling me that why I am not solving the question from the assignments. So this was for the last week only I taken one question directly from the what assignment. Okay, because this question is slightly difficult to understand. Okay, so that's the reason I directly taken, and I will show you how it's done, which will be helpful for your assignment questions. Okay, maybe similar questions are there in your assignment. Okay, so question is, a single stage axial flow turbine operates with an inlet temperature of 1100 Kelvin and total pressure of 3.4 bar. The total temperature drop across the stage is 144 Kelvin and the isentropic efficiency of the turbine is 0.9. The mean blade speed is 298 meter per second and the flow coefficient is 0.95. The turbine operates with a rotational speed of 12,000 rpm. If the convergent nozzle is operating under choked and condition, determine blade loading coefficient, pressure ratio of the stage, and the flow angles. Okay, this is the question. Okay, and the corresponding diagram is already given. Okay, not given, I already drawn for you. Okay, in the exam this kind of a diagram may or may not be given. Okay, so you should know how to draw this kind of diagrams. I think these things are how to draw this diagram, all these things is already covered in the theory. Okay, so the first bit is A. The blade loading. Okay, that is blade loading defined as psi is equal to Cp delta T naught divided by Q square. Okay, so 1148 into 144 divided by 298 square. Okay, Cp, everything given, you see, Cp given. Where is Cp? Okay, Cp is not given, but Cp you should find out. Okay, for the corresponding mean temperature. Okay, get it? Okay, so what is the value? 1.8615. This is your answer. Okay, similarly second bit, T02 is equal to T01 is equal to 1100 Kelvin. Okay, then what is T03 is equal to T01 minus delta T naught. Okay, so 1100 minus 144 is equal to 956 Kelvin. Okay, then what is the isentropic efficiency of the turbine? Is equal to T1 minus T3 divided by T1 minus T3 S. If you solve, delta T naught divided by T1, take common, I apply the isentropic formula, isentropic flow formula, P3 by P1 to the power gamma minus 1 by gamma. Okay, so P3 P1 is equal to 1 minus delta T naught divided by efficiency of the turbine T1 gamma by gamma minus 1 . Okay, if you solve it, you get 0.533. Okay, what is the pressure ratio of the turbine? What? P1 by P3, yes or no? So 1.875. Okay, that thing we get it from here. Okay. Okay, so you see P3 by P1 0.533. Just take the reverse, you will get P1 by P3. Okay, 1.875. Now what is P3? Because you know P1. So what is P3? P3 is equal to 1.813 bar. Okay. The pressure ratio of the stage is your what? P3 also you know, P1 by P3 also you know. Okay, so this is your answer. Okay, so now let's go to the turbine in stage. Okay, so next question, sorry, next bit. So the nozzle is choked. Given nozzle is what? Choked. That means here exit Mach number equal to what? Unity. Okay, that means C2. Sonic speed is your square root of gamma R T2. So T02 by T2 is equal to what? Gamma plus 1 by 2 is equal to 1.165. Okay, so the static temperature is what? Already there, T2, I think we find out. T2 already you see. T2 is, T02 is 1100 Kelvin. But if you know the ratio of T02 by what? T2, just put the T2 and find out the what? Sorry, put the T02 1100 Kelvin. This you know. Okay, so static temperature. T2 944.2 Kelvin. So the absolute velocity of the gas leaving the choked nozzle is what? What is the absolute velocity? That is C2. Okay, so C2 now will be your what? Okay. So now what is the C2? 600.3 meter per second. If you solve in the formula, okay. So axial velocity is equal to CA is equal to U into 5, okay, is equal to 298 into 0.95. Everything given, okay. 0.95 is your what? Flow coefficient, okay. And the 298 is your what? Blade speed, mean blade speed, okay. If you do it, you will get 283 meter per second, your CA. And if you see the velocity triangle, cos alpha 2 is equal to CA by C2. 283 divided by 600, 0.4716. Alpha 2, put it, take cos inverse, find out the alpha 2 was 62 degree. Okay. Now you get what? Alpha 2. So now if you get alpha 2, that means U by CA, you can do it, that is from triangle you can get tan alpha 2 minus tan beta 2 is equal to 1 by 5. So tan beta 2 is equal to tan alpha 2 minus 1 by 5. Okay, if you solve you get 0.828. Okay, so now what is beta 2? Beta 2 is your 39.6 degree. Okay, the turbine specific work. Okay, what is turbine specific work? The turbine specific work Wt equal to Cp delta T naught is equal to U into Ca tan alpha 2 plus tan alpha 3. And if you solve, your tan alpha 3 is equal to Cp delta T naught divided by U into Ca minus tan alpha 2 is equal to 1148 into 144 divided by 298 into 283 minus 1.8807 0.0793. So what is alpha 3? 4.54 degree. Okay, so you got your alpha 3. Now if you have alpha 3, then U by Ca is equal to tan beta 3 minus tan alpha 3, or implies tan beta 3 is equal to 1 by 5 plus tan alpha 3 is equal to 1.132. So what is beta 3? 48.54 degree. Okay, so what asked in the question, what is the flow angles? Okay, flow angle here, what, alpha 3 and beta 3. Okay, get your answers. Okay, not only this, alpha to beta 2 also flow angles. This is also answer. This is also answer. Okay, with this we end this extra live discussion section of week 12. Okay, you can see the complete video of week 12. Okay, and after that maybe you can also get to know some of the problems. Okay, similar problems are also there in the week 12 live discussion sections. Okay, and this is the extra live discussion section for the week 12. Okay, because some of the concepts and some of the problems are not discussed there at that section, and these things I discussed here. Okay, in this section. Okay, thank you very much for attending the section. Okay, happy learning and good night.